In this episode, Sasha and Keoni use what they know about special points to explain why increasing the p-value results in the parabola getting wider on the coordinate grid. They begin by thinking about how to express a special point for any parabola with an unknown p-value.
Could you put the special point on for this one?
You can try. Right? It'd be like right there, right? Right there.
Well, this is the 2p, comma p, right? Because the x is double the y?
Yeah.
Yeah. Okay.
2p, comma p. Because the distance from there to there is equal to the distance from there to there.
And what are those two distances?
Right here, the distance from our focus to our point.
It's 2p.
Yeah.
Can you draw
That's
those in? What is that distance?
2p.
Okay.
Or x value.
And then this is also 2p.
Right. And where's P?
P is the distance right here. And P could also be seen right here.
Okay.
Yeah.
And Sasha, what else are you seeing? You
I
said
just wanted to circle that one.
Oh, I'm sorry.
And you said something about an X and a Y?
Okay, so then this right there is going to be our y value.
Okay.
And this one right here
It's our x
is
value.
our x value.
So can you use this general argument this general representation of the special point to explain why as you increase P, you're going to get another parabola that's wider than the one you just had?
Because for every y you have, it's going to be double the x because it doubles.
Wait. For every y you have, it's going to be double the x?
No.
Or for
X is double the p.
Yeah.
That one. There we go.
Okay. So as I increase P, what's happening?
Your x is increasing as well.
And your parabola is going to be wider.
Well, let's go back to P as 1. So what happens to the special point if I increase P from 1 to 2?
As p is increasing, so here we have 2 and 1, because our p equals 1. And then when we have p equals 2,
Our x is
our
now
x
4.
is now 4. So it's increasing and the parabola is getting bigger because x is increasing.
What if you now increase the P from 2 to 2.5?
It increases more.
What increases more?
Our x and our y.
Well, both values increase, but the x was still double the y.
The X is still double the Y. And why is that X doubling the Y forcing it to get wider as opposed to skinnier?
Because your x-axis is the horizontal line, so then as that one's going out, since it's doubling, it's going to be going out wider faster. So then it's wider.
Sasha just made an argument that adds something important to what has already been said. She said that because your x-axis is the horizontal line, so then as that one is going out, since it's doubling, it's going to be going out wider, faster. She's referring to the fact the x value in a point, x comma y, controls the horizontal distance represented by the point. Look at the special point, 4 comma 2. When the p is 2, this point is 4 units to the right of the y-axis. As you increase the p-value by just 1/2 of a unit to 2.5, the y-value also only grows by 1/2 a unit because the p and y values are the same, but the x value grows faster. It increases by 1 unit, so that the x value in the special point on the new parabola will be double its y value. This is another way to see why the parabola is getting wider as p increases. This is an important idea, but it is challenging for Sasha and Keoni to express, so the teacher asks them each to revoice the idea.
Yeah, I see that you found that you could express a special point for any of these parabolas going through the origin as 2p.
Mm-hmm.
And could you use that or use this to explain why that means that as you increase p, the next parabola you get is going to be wider than the one you had?
So we said it was going to be wider because, so then when x is doubled your y, your x-axis is the horizontal line. So since that one's doubling, it's going to be going out wider faster than it's going up. So then it becomes a wider parabola.
Okay. And Keoni, can you revoice that or say it in your own words?
Yes, can I use this though?
Yeah, just switch over to the one you want.
Okay.
Slidey.
So basically, what Sasha said was that our x is double our y. So every time our p increases, our x is still double our y, and our x is our horizontal line, so it'll be going out faster more than it's going up.
Both Sasha and Keoni express the idea that as p increases, the special point for the parabola will be growing faster out than it grows in the upward direction. As Keoni put it will be going out faster than it will be going up. This lesson started out with Sasha and Keoni stating the relationship that they had discovered in the previous lesson. As p increases, the parabola gets wider. As p decreases, the parabola gets skinnier. Then they created 3 different arguments to explain why this relationship holds. In each argument, Sasha and Keoni used comparable points. 3 points that shared an x value, 3 points that shared a y value, and 3 points were special points. Each argument helped give a deeper understanding into the nature of the relationship between p and the graph of the parabola.